Hi, this is Subhrajit Bhaumik from Wagner High Quality Lubricants, and I am going to introduce to you the next generation lubricant, which is Wagner Microceramic Nanoglide Compounds. Now, our Nanoglide Compounds is a patented technology of Wagner High Quality Lubricant. We have evaluated different technologies, and we found that the microceramic glide compounds have outperformed other technologies such as the molybdenum disulfide, graphite, sulfur, and phosphorus additives. The main disadvantage of the standard solid lubricants such as the molybdenum disulfide is that it is stable up to 400 degrees centigrade. When the temperature exceeds 400 degrees centigrade, the molybdenum disulfide disintegrates, liberating sulfur, which will form acids and will be corrosive to the metal surfaces, seals, and paints. The Wagner microceramic glide compounds do not contain any sulfur, and hence there will be no acids and no question of corrosion to the metal surfaces, seals, and paints. The microceramic additive can be used in mineral oil, synthetic oil, semi-synthetic engine oils, and it comes in two varieties, that is the automotive microceramic oil and industrial microceramic oil. The main advantages of using this microceramic oil additive are its reduction in friction between the tribopairs, reduction in power consumption in gearboxes, compressors, spinning mills, and many other applications. It reduces the oil running temperature, it reduces emissions, and it enhances the performance of the equipment. We have found that 10% by volume is enough to enhance the tribological properties in case of automotive microceramic oil applications. And in case of industrial microceramic applications, we need to add 5% by volume. We did a lot of tests, and one of the tests which we are going to show you here is the anti-wear test parameters using a 4-ball tribometer, where we had applied 750 newtons at an RPM of 1200 RPM and a 75 degrees centigrade. We used 320 CST of gear oil, and we optimized, and we found that 5% by volume is the optimized concentration which needs to be added to these kind of gear oils. With the addition of 5% by volume of Wagner microceramic additive oil to the commercially available gear oils, the coefficient of friction was 22% less than the commercial gear oil without Wagner microceramic additive. The wear scars were 44% less in case of Wagner microceramic additive as compared to the commercial gear oil, which did not contain the microceramic additive. On looking into the wear scar surfaces, we found that there were deep grooves which were formed as well as progressive pits on the ball surfaces of the 4-ball tribometer. In case of the commercial gear oil, which did not contain the microceramic additive, but the wear scars was very normal, and the surface did not show any kind of damage when a microceramic additive was added to the gear oil. This indicates a stable lubricating film between the tribopairs in case of Wagner microceramic additive gear oil. In case of the modified Brugger test rig, we found that about 15 to 21% of less current was consumed during the tribo test in presence of the microceramic additive in the gear oil as compared to the gear oil without the microceramic additive. The roughness parameters also indicated that the surface roughness in case of the microceramic additive was lesser as compared to the surface roughness in case of the gear oil, which did not contain the microceramic. This indicates that there was a lot of unstable lubricating film in case of the gear oil, which did not contain any microceramic additives to it. The tests were also done with 15W40 engine oil, and where we did a test using a 4-volt tribometer with an applied load of 392 newtons. The oil sump temperature was 75 degrees centigrade, and it was running at 1200 RPM. We found that with the addition of 5% by volume of Wagner microceramic additive, the frictional torque was much lesser. This indicates that there was a very stable lubricating film between the two tribo pairs. Now, how does this microceramic nanoglide compounds work? These nanoglide compounds, they contain a lot of nano-sized spheres that drastically improves the lubricating abilities of the lubricating oils. Billions of ceramic spheres enter the crevices on the metal surfaces, which increases the load-bearing capacity, as well as does not allow any interaction between the metal surfaces. These spherical shape of the ceramic particles allow them to act as nanoball bearing, reducing the friction between the metal surfaces and lowering the running temperatures. We have also tested the load-bearing capacities of the molybdenum disulfide greases as comparison to the microceramic greases. We found that the well load of molybdenum disulfide grease was 4000 Newton, whereas the microceramic grease was 5000 Newton in one of our product, which is Li200, and in another of our product, which is Li400, the well load was 8000 Newton. This indicates that the microceramic greases have high load bearing capacity than the molybdenum disulfide greases. We have added these microceramic additives to ISO VG10 spindle oil, and we found that a reduction of 9.05% to 10% in instant power in the running operation. So it was a huge payback for the spinning mill. Additionally, when we look into the leakage tendency test, which was done at 105 degrees centigrade at 660 RPM for 6 hours, we found that there was no damage on the surface of the bearing in case of our microceramic grease of Li300 RNG. There were no gumming of the grease in case of our Li300 RNG as seen in the picture on your left hand side. The commercial grease, you can see a lot of gumming was formed on the bearing during the test, which was absolutely not there in case of Li300 microceramic grease. When we looked into the oil leakage, we could not find much of the oil, and in case of Li300 microceramic grease, about 83% less oil leakage was found as compared to the MP3 grease. So this indicates the better formulation of our microceramic greases and the very stable lubricating film formation, for which there was no surface damage was observed on the bearing surfaces, whereas a lot of scars were observed on the bearing surfaces when we were using the commercial MP3 grease which is available in the market. So the main advantages of using the microceramic lubricant are, in case of industrial applications, the microceramic greases have very high load bearing capacity. They reduce power consumption, they reduce the gearbox temperature, they reduce friction, increases the oil change intervals, and makes the equipment sound very smooth. We have also found in the automobile applications that with the addition of microceramic additives in the engine oils, there was a significant reduction in the emissions, there was reduction in the oil temperatures, there was reduction in frictional wear, the mileage was enhanced, and there was an increased oil change interval. And additionally, we also found that there was a smoothing of the transmissions. So this is what our microceramic nano additives enhances the performance of all the equipments when they are added, when the oils are added with the microceramic additives. So our team and we look forward in receiving your inquiries. Thank you.